Alright, welcome back. We're doing another free response on related rates here. And here we've got, looks like this, a little cone that's a tank that's dripping water into a big cylinder tank. Why, I'm not sure, but regardless, let's see what we have here. It has a height of 12, this little cone right here, and it has a radius of 4. It gave you the diameter of 8, and the area of this, not the area, excuse me, but the volume of this cylinder tank is equal to 400, right? pi square feet. No, it's area, you're right. So the area of that, what kind of area? With a base, where the area has 400. So we don't know how tall this thing is, but anyway, let's see what we need to figure out. The depth h in feet of the water in the tank is changing at a rate of h minus 12. So dh dt is equal to whatever the height is minus 12 feet per minute. They gave you the volume formula, which is helpful, and they usually do. Write expression for the volume of water just in the cone as a function of h. So we're going to have to get rid of the radius squared, right? Well, the property of a cone is that it maintains a certain ratio, right? It's 8 feet at the diameter is 8 feet, but that's only when you're at the very top of the cone, which is 12 feet. So let's just write a ratio here. We have the height to radius is equal to 12 over 4, which is a 3-to-1 ratio. And so if we're trying to rewrite this volume formula, pi r squared times h, but we want to get rid of the radius, well, not get rid of it, but write it in terms of h. So h would equal 3r, or more importantly, the radius is equal to h over 3, right? If you just cross multiply that and then divide by 3. So I'm going to put in my h over 3 right here, and I sure did almost make a mistake, didn't I? There's also a 1/3 in that formula, right? We're dealing with the cone. So if you rewrite this formula, you get volume equals 1/3 pi h squared over 9 times another h. Simplifying that all together, you get 27 as a denominator. And we can write it like that because that's going to end up being our constant, right? And h squared times h would be h to the 3rd. So that's volume written with respect to h. Part A, no problem. Part B, at what rate is the volume of the water in the cone changing when our height is equal to 3? So we're looking for dV dt, and we already know what dH dt is, right? In fact, let's see if we can bring that down here so we don't have to rewrite it. We know dH dt, and we want to know when the height is equal to 3. When the height is equal to 3. So, well, let's just take the derivative. we'll take the derivative of this volume equation, and we get dV dt is equal to 3 times pi over 27 h squared dH dt. Alright, notice it was helpful to write part A because now we don't have to have a dr dt, and let's just plug in. So we have that 3 over 27 reduces to 1/9, right? So we have pi over 9, and when the height is equal to 3, and now times dH dt, which is this guy right here, h minus 12. So h minus 12, let me grab a pen, 3 minus 12. That's from the given, right? That's dH dt. Okay, and this is equal to dV dt, which is what we're trying to solve for. So this becomes pi over 9 times 9 times a negative 9, right? Canceling out, we get a 9 and a 9, cancel out, and it's equal to negative 9 pi cubic feet. Try that again. Cubic feet per minute. And I think that's it for part B. Part C says, let y be the depth in feet of the water in the cylinder tank. At what rate is y changing when h equals 3? Indicate the units of measure. So, what do we know about the volume of a cylinder? Whoops. Let's do that right here. And let's do green for this, I suppose. Volume is equal to, pi r squared times h. Well, they kind of already told us that this cylinder tank has an area of 400 pi, right? So we don't have to worry about this portion of the formula because this is always consistent, right? So this is what volume is equal. And if we take the derivative of this, what do we get? We just get dV over dt is equal to 400 pi. The derivative of that to the first power just goes away, right? 1 times 400 pi. But we have our dH dt, right? Alright. Okay, now what do we know about the height? What's the height changing? Okay, so from the first part, let's see if we can make some sense out of this. This dV dt was water coming out of the cone, right? Coming out of our cone, and it was dripping into our cylinder, right? So if it's coming out of the cone, that's why this is a negative unit. But that means it's coming into the cylinder as a positive quantity, right? So we can replace this dV dt with a positive 9 pi cubic feet per minute. If you want to use your units here, you can. Certainly we'll put them in on the answer. And this is 400 pi dH dt. And then we're looking for DHDT, so we divide this thing out. Get some more space here. If we divide by 400 pi, we get pi's cancel out, of course. We get DHDT, changing at, and remember we're dividing by this 400 pi, but the units here on 400 pi, that's the area, right? Which is square feet. So if we divide that out by 400 pi square feet, that's going to cancel two of these. So we're just going to be left with feet per minute. So DHDT is equal to 9 over 400. And of course this is positive because it's rising. And the units here would be feet per minute. So I think one of the big secrets on these problems is to actually think about your units as you're canceling out, and that'll kind of ensure you that you've taken the right, either the derivative or the integral or whatever the problem is asking. It'll sort of ensure that you're on the right track, because if your units don't make sense in the answer, then you probably made a mistake somewhere in your logic. So anyway, I hope these are helpful for you, and just keep practicing. The more you see, the more you practice, soon you'll be able to do these second nature without, not to say that they're easy, but certainly there is some patterns that form, and you are gaining some skills in setting up logically your problem, and I think you should have great success. Alright, see you